Hello, welcome back to the second part of week 3 of the ECE9013 course. In this part, we will be exploring different search methods. The first method is the guess and check method. This process is also called exhaustive enumeration. So using this method, we are trying to guess a value for a solution, and then we check if the solution is correct. So given a problem, we start with a guess, we check if the solution is correct. If not, we make another guess. So this continues until we find a solution or we have guessed all values. So for example, assume we are trying to determine the cubic root of a number. So we start off by asking the user to input a number. Then we would have predefined the value for guess and say for guess in the range of absolute of cube plus 1, if the guess raised to the power 3 is greater than the absolute of the cube, we break. And this is because, mathematically speaking, if the cube is larger than the number, then the guess is a lower value. After this for loop, we check if the guess is different, or the guess cube is different than the absolute of the cube. Then we say that the value inputted here is not a perfect cube. Else, which means that we could find a value for a guess that is a cubic root. If the cube is positive, then guess is the cubic root. If cube is negative, we just change the sign of the guess. And here we print out that the cube of this input number is the guess. The second search method is what we call approximate search method or approximate solutions. So in this case, we are looking to find a good enough solution. So we start with a guess and increment by a small value, and then we keep guessing until the difference between the cube of the guess and the value of the cube number is small enough. So this is done typically to reduce the complexity of the problem, because we don't need to find the exact cubic root, but rather a close enough estimate of that cubic root. So in this case, if we decrease the increment size, it means that we will probably need more iterations to reach a close enough value. If we increase epsilon, we might get less accurate solutions. So there is a balance and a trade-off between the speed of the program and the accuracy of the answer. So going back to our previous example, here we define that the error margin that we would like is to be within 0.001 of the actual value, and we're moving with an increment of 0.0001. So we say that while the absolute of the guess cubed minus cube is greater than epsilon and the guess is less than the cube, we increase the guess by the increment and we increase the counter by 1. So once we exit this loop, so either when we reach a close enough solution or we have exceeded the value of the cube, we print the number of guesses and say and check basically if we have a close enough solution or not. So this is another way to find the cubic root of a number using an approximate or an approximation method. Last but not least is the bisection search method. So in this method, we actually only search within half of an interval in each guess. So this reduces the search space with every iteration until we reach a close enough solution. So in this case, again, we would define the margin of error that we would like in epsilon. We define that the lower margin or the lower end of the search space is 0 and the highest potential value for the guess is cube, and then we take the midpoint of that range and we check whether, using a for loop, whether the guess cubed minus cube is less than this epsilon. If the guess cubed is less than epsilon, then we move the lower end of the search interval to the midpoint, which is at guess, or we specify that we move the higher end of the search space to that value of guess, and then we recalculate the midpoint of the new interval. So the idea is, in every iteration, we reduce the search space by half and redefine the guess value to be the midpoint of the new interval. So using this method, in the first, or when we perform the first guess, the search space is of size n over 2. In the second iteration, it would be n over 4. So the guess variable converges in the order of log base 2 of n steps. So this method works whenever the value of the function varies monotonically with the input, which means that the function we are trying to solve or try the solution for either is always increasing or always decreasing. And note that this method only works for positive cubes. So in the class lecture, we will try to modify this code for it to work with negative cubes. Thank you.